Okay, everyone. Hello, everyone. I'm Ryan. And MLiS is here. And this time, I'm going to share with you the MLiS Electric Label 8 AI Starter Kit, MLB-EmCore3568. This is a demo about how to set up the MLiS AI Edge computing board in this webinar. We are using the Zoom to broadcast. During the presentation, if you have any question, please type it in the chat room. We will reply after the presentation. In today's webinar, we are going to share with you about the HAI, the starter kit, MLB-EmCore, the 3568, and it's the whole series. We ready the product from the one task to the 64 tasks, and how to build out some features for the MLB Edge computing boards step by step, such as the Boolean test, Wi-Fi test, even build out a hello world program into this board. First of all, I would like to share with you some scenario for this AI computing board. In today's webinar, we have a packaged agenda diving into the three major parts. First, we will effort to verbalize the scenario to see how the AI edge computing is transforming industrial different applications. Second, we will dive into the key features of the MLB-EmCore 3568 to understand its hardware performance. Finally, we will have a hands-on demo where we will show you the live setup and the AI interference process step by step. Let's start with the first application category. Smart vision and the civilian. With the built-in NPU celebration in the MLB-EmCore 3568, it can perform the complex tasks right at this stage. Common use case, including the AI facial recognition for security, detection on the automatic production line to ensure the quality, and empowering intelligent NVRs for advanced video management. This reduces the need. Let's start with the first application. Next, we will look at the industrial edge control. In model the small factory, reliability is everything. The MLB-EmCore 3568 acts as powerful end-to-end gateway, enabling the streaming-less communication between the machines. Its high performance allows the low latency data processing, which is critical for the automation robot and the real-time decision making on the factory floor. Now, let's take a close look at the front of the board. The core of this kit is the ROD chip. Is the ROD chip RK3568 and the real-estate operation. First, entry-level AI asset celebration instead of the overplaying for the massive compute power you might not need. The board features and efficient one task NPU, is the MLiS support the visual framework like parser the flow, the file touch, making it ideal for running the functional visuals task without breaking the budget. Efficient performance. It runs on the Cortex A55 CPU up to 2 GHz. Ensure the smoothly the system operation and the multitasking while maintaining the excellent power efficiency. Industrial reliability. Here is the most important part. It supports the wide temperature range from -40 to 85, making this the entry level for the truly ready for the harsh industrial environment. And flexible storage. You can choose the 8 gigabytes to up to the 35 gigabytes. And the TFT cards, SATA extension. Okay, let's take a look at the hardware. Here is our board, and then this one is MLB-EmCore3568, and then this one is the raw chip. And here is a major board. You can embed this one into your device, just like the machine arm and LED the display and the PLC, something like industrial devices, without the operation the build up. See operations system the build up. And this one is starter kits. We reserve the different interface over there, just like the power, Type C. It's used for the configuration, Ethernet, I/O, and the serial ports, and you can use Ethernet for the communication with this boards. And we also reserve the USB 2.0 and the mini PCIe slot. In here, you can use the mini PCIe card, something like the LTE module card or a Wi-Fi module card, and insert here and install the driver into this board. And it can build out the wireless connectivity on this board by yourself. Of course, for this card, we also reserve the Wi-Fi connectivity on this board. Later, we will show you how to the demo and how to build up the demo setup. For this case, we're going to share with you how to set up and build out some features of the MLB-EmCore3568. First, we are going to show you how to set up the test environment. Here you can see, here is a picture for the test environment, and here is the topology, how we connect with this board. And here for this board, need to connect to the PC by the Type C, and it is used for the configuration and set up some parameters into this board. And for Ethernet, we use it for the communication. And of course, you need a power on. In here, we use the putty. To do the configuration to set up this board. And we also prepare the TFTP, the server. After, we will upload some program into the list board. And of course, we in final we have a power on the list board and log in the console. Here as here you can see, we use the type C. This type C to the USB to the PC, and then later we will open the PuTTY on the PC to configure this board. And then sometimes we use the Ethernet to communicate with this board as well. Okay. We control the GPIO to make a learn as the following steps. The GPIO declaration of formula is just like here. We change the GPIO pin as the booster. And here you can use this function to calculate the GPIO, the booster pin. And here we in this table, our booster GPIO pin is 50. And then we type these 4 commands into the list board to control the GPIO and then make the GPIO as the booster and then it will BP. And here, echo 1 means the turn on the beeper, a booster. And then echo 0 is turn off the booster and the start beeping. Now, the technical support Andy, he will help. He will demo this test for you. Here, now here we already set up the echo 50 as the GPIO, and then we changed we enable this GPIO 50 to the list direction, and now we will turn on the beeper. Because with the Zoom will filter the beeper sounds. So, okay, now we're going to turn off with the booster. Okay. So this is the first one. How to set up GPIO as the booster and make the noise on it. After the booster pass, the second one is the Wi-Fi test. First, we set up the SSID and the password into the list board. And then we show the file Wi-Fi point.sh. You can see the content over here. You also can base on it to modify as you want. Now we're running the Wi-Fi sh this execution, and it will get the IP configuration over the DHCP. And then we use the ping function. To show up the network working the board. And then your board will get the Wi-Fi connectivity on your board. You can use the Wi-Fi to access the no matter the LAN or WAN over there. We go into demo. Okay. Now we change the direction to the Wi-Fi one. And then we set up the access ID and the password into the this board. And then let us show you this file over there. Of course, you can based on the Wi-Fi configuration to modify on it. And then we are running the list execution. Here you can see we are broadcasting together the IP configuration, and here you can see we get the IP address in here. Now here we check the IP configuration. You can see we get the IP configuration from the DHCP. So it means the list 4 already get the network. And then we use the ping function to make sure we can access the web. And here you can see we ping the DNS, the server, and then we can get the data back. For this action, this action can make sure we can access the web. Most important one, the fact how to build out the hardware program into this board. As we know, hardware the program is most the best example for engineering. All of the project is all of the program is started by this. So here we are teaching how to build out this kind of program on this board. And you also can make the more complicated program to extend its usage at these steps. First step, you have to build out the development environment of your PC. And here we install the VMware and the Ubuntu 18.04 in PC. And then we copy the compilation, the software to the VMware. If you don't have them, we can provide this image to you. Then set up the compilation environment and check the GCC version. Today we are using the 9.3.0 this version for your compiler environment. Then check the Hello World the program. After the compiler and generate the Hello World file, and then we copy this from the VMware to the PC. And then we try to upload this file from the PC to the embedded board. And then make sure the PC can connect to the MLB-EmCore3568 port, the 3568 via Ethernet. Here we set up the IP configuration. And then we use the TFTP and transport this file to this port. And then we execute this file to see the result. And you can see the hello world. This string printed in this console. Because we have complete the compiler the environment and it detecting some minutes. So today we will skip this step to build out the compiler environment. First, install VMware and Ubuntu in PC, and then copy the configuration software to VMware. And we can provide the image. That's the comparison software is the one. Here, we already built up the compiler and the development environment here in this VMware. So here you can see we log in our VMware and start to do this program. And next, now we are setting up some parameters in this VMware to measure our compiler environment or the safety good. And check out the GCC version. The GCC version is 9.3.0. And we can see the C file of hello world. It will show the hello world screen. Next, compile the C file hello world. And this hello world is most basically the program on it. Of course, you can base on the C language to modify the hello world, this program, and put in some features or some functions you need in this hello world, and to extend its usage. You can see the file hello world in VMware side. This is the general compiler file hello world. And copy the compiler file hello to PC. Now we are trying to the compiler generation the file hello world into this board. You can see the hello PC side.
The IP of the board is 192.168.1.1 meter. You can see.
Because now we are uploading the lower the file to the list board, so we have to make sure the list board the network is working.
And set up the Ethernet IP of the PC. This is 192.168.1.11. And you can see the IP of the phone can connect to the Ethernet IP of the PC. And now open the TFTP server. Select the path of the compile file in TFTP server. And I put the file hello in this table. So select to the path of this table. Okay, now push the compile file hello from PC to the board by TFTP server. You can see the hello world is at the home demo in the console.
Now we are connecting back to the list board and running the hello world list function. Like here you can see the hello world screen is printing.
You can see the very hello. Okay.
Okay. Here is the three demos, and we show you the router, the test, and the Wi-Fi test, and how work fill in the list work. And I think the most important one is how to build up your own program to this hello world, to this board, and then if you need some samples, you can get from us. And for our technical parts, we will support you how to deploy your own program into this board. And any question? If you have any question, it's okay. You can just mail me and let us know. Here is our content. You can contact us or you have my email address. We will support you to how to build out your function on this board and how to test this board. Okay, thanks for your time to join. Please subscribe the MLiS SMS, like YouTube, Facebook, LinkedIn. We will release more news on about the IoT market and the coming webinar. We'll see you next time. Thank you.